Hello, scholars. Welcome back. I am broadcasting this lesson from my office here at Augusta University in University Hall. And today we are talking about data analysis and results, examining what was found in a quantitative study. And this is adapted from our textbook, Plano Clark and Creswell's Understanding Research and Consumer Guide, second edition, and this is from chapter 8. Okay, so let's jump right in. Slide 2. Okay. How do researchers use inferential statistics to answer comparison and relationship research questions? Now, if this were an intro to stats class, I would spend a lot of time on the content we're going to cover in these next couple of slides. But since this is an intro to research class, we're going to go through this a little bit quickly. But I want you to understand it because it's the foundation basically on which a lot of quantitative data analysis is built. And it's this process, first of identifying hypotheses, then for setting criteria for setting the criterion for making a decision, and then we collect the data, we compute a statistic for the sample data, and then we make a decision about rejecting or failing to reject our hypothesis. Now, the type of hypothesis we identify first is called a null hypothesis. And basically, the null hypothesis is that nothing happened. Our intervention didn't work. The students did not improve. The clients were not less depressed. The athletes were not faster or stronger. Okay? So the null hypothesis is that there was no change if we were looking for change, or there was no difference if we were comparing groups. And so sometimes it's called the straw man hypothesis because basically we want to knock that down. With the alternative hypothesis, which is that our intervention worked. The students learned, the clients got better, the athletes also got better. Okay. And then the criteria that's usually set, the alpha value that's usually set is zero point zero 0.05. And this has to do with probability. Basically, an alpha value of 0.05 means that 19 out of 20 times of doing the same activity, the same intervention again and again, 19 out of, if our alpha value is less than 0.05, we're saying that 19 out of 20 times we expect that if we compute a difference, there actually was a difference. If we think that if we compute a gain, there actually was a gain, or there would be a gain in the population, even though we are computing statistics for our sample. So 0.05 is almost always the alpha level. We collect the data, right, from our sample. Now we're computing a statistic for the sample's data, and our idea is that our hypothesis relates to the population. Okay, so we have a sample, we have that smaller group of people that we hope are representative of a larger population. And we're going to make a decision about rejecting or failing to reject the idea that if we were to do our intervention with this larger population, there wouldn't be a difference, right? So, yeah. So those are basically the steps in terms of doing inferential statistics, inferring from a sample to a larger population. Okay, so what is this stuff about alpha level and that kind of thing? In a nutshell, a lot of classic statistics is based on the idea that um, that the averages that we get from multiple samples will come out to be in a bell curve, right? So, and so that so it's easiest to think about this as differences, as pre-post, kind of pre-post test, because that's something we're used to. We're all in school, right? So let's say I were to give you a test of your intro to research knowledge at the beginning of the semester, and then give you the same test at the end of the semester, and then compute a score that showed the difference between your end of year, end of semester, and beginning of semester scores on that test. Um, and each of you in the class would have a score. Let's say to take an average for this class, right? Basically, the distribution of sample means is if we have an average for our class, well, what if we also had averages for the classes that took it last semester and the semester before and the semester before that? And how about averages for the classes that took it at other universities? Okay, then we'd have a lot of sample means, and we'd find that some of the classes learned a whole lot, and those would be represented by on the high end of our bell curve, and some of the classes didn't learn a whole lot, and those would be represented on the low end of the bell curve. But we expect most of the classes would have learned somewhere close to the average, right? Necessarily because the average means, where most of the people fall generally, if you have a bell-shaped distribution. Most of the people we would expect, most of the classes we would expect to have an average somewhere here in the middle, right? So the the we'd expect the differences to be somewhere in the middle, right? Now, if we find that the difference is way over here, let's say we find that, um, um, you know, our students doubled or tripled or quadrupled their knowledge of intro to research content, then we would expect, and that is a rare occurrence, then their average would be plotted somewhere over here. Now, let's say the intro to ed research class was actually harmful and students came out knowing even less than they did going in. The difference between their pre-test and post-test would be very low, and we would know that the intro to ed research class did something. It wasn't necessarily good. Okay, but most classes we would expect the average of the differences in their score from pre-test to post-test to fall somewhere around here. Okay, and so if we do get uh, averages somewhere on the tails, what are called the tails of the distribution, then of sample means, then we know that the intro to research class did something. Maybe it did something really well, or maybe it did something brain numbing. If this were an intro to stats class, we would spend a lot of time on the normal distribution. Um, um, because it is so foundational, I just wanted you to hear some of the language, okay? Tails, distribution, alpha level, null hypothesis, sample means, that kind of thing. That's what I want you to take away from this, okay? All right, so how do you identify the quantitative data analysis and results? You're going to look in the methods section. Where's the paper? I meant to print out a paper that I could show. Oh, here's the Journal of School Leadership. Where's my other one that I was going to talk about today? I really got to clean up this office. Okay, here's the Journal of School Leadership. Um, and this was September 2017, and I am in here. Woohoo! Okay, where am I? Okay. So you're going to look to identify the quantitative data analysis and results. You're going to look in the, where am I? I should have marked that page. Oh, I know. Here we go. Okay. So you're going to flip through. Well, okay, here's how I read journal articles, particularly when I'm in a hurry. I read the title, I read the subtitle. Sometimes you can basically know a whole lot about the article if the title and subtitle are well written. Then I read the abstract. Some abstracts are more informative than others. And then, particularly since I'm into research methods, I skip to the section that says methods or methodology. On this paper, I called it methodology. And I start skimming that. Okay. Now, sometimes they mention the research questions before the methodology. I really do want to know the research questions. Um, and so I look for those also. So I'm flipping through, looking at reading the methodology. Okay. And so that was it for this. And then the part that we're talking about today is basically the data analytic plan. Which in this paper I put over here. But I'm going to show you an example from a paper. This was 2017. But I'm going to show you. I'd like to show you some examples from my very first peer-reviewed published journal article, and that was published in 2012. Okay, title. Feelings of preparedness among alternatively certified teachers. What is the role of program features? Oh, I just realized that rhymes. Okay, so first off, to understand the study, we've got the title and the research questions. I had three research questions, and I was interested in this idea. Okay, so all throughout the late 90s, early 2000s, there was this tension, this battle, this conflict between traditional teacher certification and alternative teacher certification. Alternative teacher certifications were programs that trained potential teachers very quickly. So the most famous example of that was the Teach for America program. Okay, and so I was looking at the role of the features or aspects of these programs that were training teachers, particularly alternatively certified teachers, to see if the teacher's feelings, their confidence, their feelings of preparedness differed. Okay, so research question one: are there differences in the personal characteristics of first year alternatively and traditionally certified teachers? Okay, so we know from that personal characteristics, that's usually the background, right? The teachers' backgrounds. And we know that we're looking at first year teachers in this study and these two groups, right? Alternatively and traditionally certified teachers. And so that would basically be like comparing students who attended Augusta University to students who attended some kind of fast track Teach in Georgia type program. Okay, research question two: do alternatively certified teachers feel less well prepared than their traditionally certified counterparts? Okay, so we have two groups in that question, and this is directional, right? Where you can almost hear the hypothesis behind the question, and the hypothesis there would be, and this is the alternative hypothesis, the alternative hypothesis would be that alternatively certified teachers feel less well prepared than their traditionally certified counterparts. And the null hypothesis there would be there's no difference between the two groups in terms of their feelings of preparedness, right? Okay, so research question three. Now, this goes into a little more detail. Sometimes the third research question is really what the researcher wants to know, and the first two questions may be kind of preparation. Do alternatively certified teachers whose certification programs have certain features, such as certain types of coursework or longer field experiences, feel better prepared than teachers whose programs do not have these features? Okay, and let's look at how I explored these questions, particularly research question three. Okay, so Let's talk about what's in the methods section. In the methods or methodology section, you're going to look for how the researchers defined the variables. Now, this in the list that's in your textbook, define the variables is not at the top. It is not bolded. I'm putting it at the top. I am bolding it. Okay, because often how researchers defined or operationalized the variables will relate to what you're going to think about in terms of the study's validity. So look at how researchers define the variables. Look at how they scored the data or assigned a value for each response. They should also talk about how they prepared the data for analysis, how they analyzed the data to answer descriptive questions, and then analyze the data to test comparison and relationship hypotheses. And that how they analyze the data should appear in a data analytics section. And then in the methods or methodology section, you're not going to see how they reported the results. So I crossed that out. You're going to see that in the results question. Okay, so here's an example defining and scoring variables. And normally I don't like to read what's on the slides because often it's too much text, like in this case, or you've already read it most likely, and you don't necessarily need to hear me read it, but there are just some things I want to point out, okay? And so I'm going to go through reading at least part of these examples of how I defined and scored the variables. So first of all, these two groups, these two routes to certification. So the principal question predictor for each research question is AC, and I italicized AC to show that it's a variable in my study. A dichotomous variable coded one for teachers who had completed or were attending an AC program or alternative certification program, and coded 0 for teachers who had completed a TC route to certification or traditional certification program. And early in the paper, I would want to define what AC and DC stand for, right? Okay, I used two main questions to distinguish between AC and TC teachers. This was a survey research design. I used the schools and staffing survey and hundreds of teachers in my sample. And this was a survey that was done by the Census Bureau working with the Institute for Education Sciences. And um, so so I looked at two questions that were on a survey that someone else had done. Um, and these surveys come in handy, these national surveys come in handy when you are looking at an issue that it's hard to, as an individual researcher, go around and investigate yourself. Okay, so, and then I say what the two questions were. And then, so that was our two groups. That's how I'm talking about the two groups. So then I talk about the outcome for research question 2 and 3, a feeling of preparedness index. Okay, prepared is a continuous teacher preparedness index that I created by compositing teacher responses to 5 questions on the schools and staffing survey. Teachers were asked how well prepared they felt to handle classroom management or discipline, right? That's part of teaching. Use instructional methods, teach their subject matter, assess students, and select and adapt curricular materials in their first year of teaching. And they responded on a scale ranging from not at all prepared, which was a 1, to 4, very well prepared. And then I say that I did a procedure called a principal components analysis, and we're going to talk a little bit more about that later. But here you can see how I defined this variable called prepared. I created this index where I composited, which it means you combine in some way. In this case, I averaged responses to teachers' questions. Okay. The takeaways from how the define and score the variables, I want you to just take away, like, as you're reading quantitative articles, take away the meaning of what happened. Try to let go of the details. Okay? It's usually not important that you know all the details. Think about reading and understanding well enough that you could give a 5 minute speech on that article. Okay, that elevator ride discussion about that article. Okay, so basically, there were two groups: traditionally certified teachers, alternatively certified teachers, and I had I had figured out, based on their responses, how well prepared they felt in their first year. Okay, so now there are certain statistical tests that you'll see again and again as you're reading quantitative papers that are used for comparing groups. I want you to just be familiar enough with the names that when you see it, it doesn't throw you. Okay. One of the things about, one of the reasons why when I tell people I teach statistics, they kind of go, is because statistics, there's all this language. It's related to math, which we kind of have a national anxiety about. And the language is esoteric. They use Greek letters and whatnot. Um, and so it's just like it's this foreign language. It relates to math. And some people have had bad experiences with statistics classes in the past. The main thing again is to get the gist. I don't want you to get thrown by seeing these labels. You can just know, oh, that's a analytic technique. That's a statistical test. Okay, there's the t-test. There's ANOVA, analysis of what stands for analysis of variance, and ANOVA has several cousins like ANCOVA and MANOVA. Okay, there's chi-square. There's Pearson correlations. There's multiple regression. Sometimes it's just referred to as regression. Sometimes OLS regression, but the main thing is regression. There's structural equation modeling. There's hierarchical linear modeling or multi-level modeling, and there's factor analysis, which is something I mentioned before, and I'm going to mention again soon. Um, um, so there are all these different types of tests. Some are used for comparing groups, some are used for relating variables. When you see these words, just, oh, that's a statistical test, or that's an analytic procedure. Okay, there's a test, it's a procedure. They threw some statistics at it. Okay. All right. So you may see one of these dreadful things. You may see some kind of equation where the researcher is showing their statistical model. And basically, we do that so other researchers, if they wanted to replicate our model, they would be able to. For the casual reader, you don't need to really pay attention to that at all. Um, but this is just says what I did. And it says that for RQ3, differences in preparedness by program features, I write, here I followed a procedure similar to the second stage described above. So I described it in more detail with RQ2. But what I said really doesn't matter because there's only one word you're looking for in this whole thing, and that is regression. Okay, so if you were to that, which is an analytic technique, right? That we know from previous slide, and so you know that I did some kind of statistical analysis and it was called a regression analysis, and that was my model. Okay. So, you know what? I'm going to pause here, okay? Because that was just a lot of information. And so I'm just going to pause and pick this up again. We'll talk about results in part 2 of the video. And so I just want to give you a chance to, refill your cup of coffee, that kind of thing. All right. Talk to you soon.